Imagine a monstrous cosmic beast lurking in the shadows of space, waiting to devour anything that gets too close. What happens when an unsuspecting star wanders into the grasp of a black hole? The result is a terrifying spectacle of destruction and unimaginable forces. Let's uncover the chilling details of this cosmic horror show. Welcome to Discover the Cosmos. Today, we're diving into one of the most terrifying events in the universe. What happens when a star meets a black hole? This cosmic encounter isn't just a spectacular show of light and energy. It's a deadly dance that ends with the star being torn apart and consumed. We'll break down the entire process, explain the science behind it, and share some real-life observations. So, grab a seat and let's dive into the fascinating world of black holes and their stellar victims. To understand what happens when a star meets a black hole, we first need to know what a black hole is. Imagine a place in space where gravity is so strong that nothing, not even light, can escape. That's a black hole. Black holes form when massive stars collapse under their own gravity, creating an area with an incredibly strong gravitational pull. There are different types of black holes. Stellar black holes, formed from the remnants of massive stars, and supermassive black holes, which lie at the center of galaxies and contain the mass of millions or even billions of stars. Black holes have an event horizon, the point beyond which nothing can return, and at the center, a singularity where density and gravity become infinite. Now, let's follow the journey of a star as it drifts dangerously close to a black hole. At first, the star might seem safe, shining brightly as it moves through space. But as it approaches the black hole, the immense gravitational pull starts to affect it. The closer the star gets, the stronger the pull becomes, and the more stretched and distorted it appears. This powerful gravitational force begins to pull the star apart, a process that intensifies as the distance between them decreases. The side of the star nearest to the black hole experiences a much stronger gravitational pull than the far side, leading to a stretching effect. This is just the beginning of the star's horrifying encounter with the black hole. As the star moves even closer to the black hole, it undergoes a process called spaghettification. This term might sound whimsical, but the reality is far from it. The star is stretched into a long, thin shape, resembling a piece of spaghetti due to the extreme tidal forces at play. These forces are so powerful that they can tear the star apart, stretching it into a stream of gas and stellar material. The gravitational pull at the black hole's event horizon is so intense that the star is pulled into a fine stream, spiraling towards its doom. The material of the star is heated to extreme temperatures, causing it to glow brightly as it falls into the black hole. This process creates a mesmerizing yet terrifying visual spectacle of light and energy. As the star's material continues to be pulled apart, it forms an accretion disk around the black hole. This disk is a swirling mass of gas and debris, glowing brightly due to the intense heat generated by friction and gravitational forces. The material in the accretion disk orbits the black hole at incredibly high speeds, and the inner regions of the disk can reach millions of degrees. This high-energy environment causes the accretion disk to emit powerful X-rays and other forms of radiation, making it visible to astronomers even from vast distances. The light show created by the accretion disk is both beautiful and deadly, a last bright scream of the star before it is fully consumed by the black hole. In the final stages of this cosmic encounter, the star is completely consumed by the black hole. The material from the star spirals into the black hole, crossing the event horizon and disappearing from the observable universe. Once inside, the star's matter adds to the mass of the black hole, making it even more powerful. During this process, the black hole can emit powerful bursts of radiation and, in some cases, gravitational waves. These waves ripple through the fabric of space-time, carrying the last remnants of the star's energy. The star is now gone, leaving behind only these faint echoes of its violent end. Astronomers have observed real-life instances of stars being consumed by black holes, providing us with incredible insights into these events. Using powerful telescopes and space observatories, scientists have detected the X-rays and radiation emitted by the accretion disks of stars being torn apart. One notable example is the star ASA Seyssen 14 Li, which was ripped apart by a black hole in a distant galaxy. Observations of these events help scientists understand the extreme physics at play and the behavior of black holes. These real-life cosmic dramas offer a glimpse into the incredible power and mystery of our universe. Studying these cataclysmic events is crucial for our understanding of the universe. The extreme conditions near black holes allow scientists to test the laws of physics in ways that are impossible on Earth. Observations of star-black hole interactions provide valuable data on gravitational forces, the behavior of matter under extreme conditions, and the nature of space-time itself. These insights not only deepen our knowledge of black holes, but also help us understand the fundamental principles that govern the cosmos. Every star consumed by a black hole adds a new piece to the puzzle of our universe, revealing more about the incredible forces that shape it. From the star's perilous journey to its ultimate demise, we've explored the terrifying and fascinating process of what happens when a star meets a black hole. These cosmic encounters remind us of the incredible power and mystery of the universe. If you enjoyed this deep dive into space's darkest secrets, don't forget to like, subscribe, and share for more fascinating space content. Thanks for watching.